Spring constant of a spring.
Formula, procedure, observations, calculations, result and units, precautions.
To determine spring constant of a spring by oscillation method. The spring constant or force constant is given by K is equal to restoring force by extension. The time period of this oscillating helical spring T is equal to 2 pi root of m by K, where m is the mass suspended to the end of the spring. If m0 is the effective mass of the spring system, which is also taken into account, then the time period is equal to T is equal to 2 pi root of m0 plus m by K. Here we want to eliminate m0. For that we are taking two masses m1 and m2. The corresponding time periods t1 and t2 are noted. Then the K is equal to 4 pi square into m1 minus m2 by T1 square minus T2 square. Procedure. Suspend the helical spring from the rigid support. To the other end, a load is applied and is suspended from that rigid support and displaced gently in a vertical plane and released. Now it is making oscillations in the vertical plane. Now, using a stopwatch, we are measuring the time for 20 oscillations. From that, time for one oscillation called time period is calculated. Now, by changing the masses m1, m2 and m3, we are calculating the corresponding time periods t1, t2 and t3.
Using this spring, we are displacing it little bit and releasing it. The spring is making oscillations in the vertical plane. We want to calculate time for 20 oscillations. Yes, we are going to start it. So, yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, we stop it and it is coming as 21 seconds. The time is equal to 20 seconds, 21 seconds for 20 oscillations. From that we can calculate time for one oscillation called time period. Now with the same load we are taking once again the time for 20 oscillations. From that we can calculate the time period using this load, and here the load is 250 grams. So the readings are entered in the tabular form given here, and by changing the load, in each case we calculated the time for 20 oscillations, trial 2, and from that we calculated time period and also t square. The readings are entered in the tabular form, and from that we calculated the K1, K2 and K3. The average K value is calculated. In this case it was observed 10.29 Newton per meter. Now what are the precautions we have to take care of it? The precautions here is that the parallax error is avoided while taking the readings. And second one, we can say that the load applied should be within the